In this video, we set out on a quest to find habitable alien worlds. But not just any alien worlds. We're going to search for life inside the Andromeda Galaxy. Andromeda is home to more than 1 trillion stars, countless planetary systems, and environments so extreme that life could take forms we can barely imagine. Life could be built on different molecules, different chemistries, or even exist in dimensions we do not yet understand. But today, our mission is focused. We're searching for worlds that could support life as we know it, planets with the right temperature, the right atmosphere, and the right conditions to sustain biology similar to ours. From ocean worlds orbiting hot blue giants to hidden Earth-like moons sheltered in the shadows of massive gas planets, we will explore them all. So sit back, relax, and let your mind travel 2.5 million light-years from home, because somewhere out there among Andromeda's stars, a habitable world might already be waiting. As you can see, we are now leaving our solar system behind, accelerating toward the Andromeda Galaxy. As our speed increases, the familiar constellations around us begin to stretch and fade, and soon the grand spiral shape of our own galaxy, the Milky Way, reveals itself as we move away from it. For the first time, we witness our home from the outside, a glowing swirl of stars, dust, gas, and history suspended in the dark. There it is, our Milky Way, our home. A luminous island of stars drifting through the darkness. We are now aiming our camera toward the Andromeda Galaxy. Every single dot you see scattered across the screen is not a star. It's an entire galaxy of its own. Each one may contain billions of stars, billions or even trillions of planets, and perhaps civilizations we can barely imagine. Now, we will initiate our warp drive and dive straight into Andromeda. Hold on. It feels like we're moving in slow motion, doesn't it? But in reality, we're traveling at thousands of times the speed of light. At velocities like this, distance itself becomes distorted. Galaxies stretch and blur, and space no longer behaves the way our minds expect. As we orbit Andromeda, we will prepare our camera to visit our first potentially habitable planet, a planet that may hold the right conditions for life, waiting somewhere among these stars. Far away, highlighted on the screen, you can see our Milky Way. Look how far we have traveled. Here we go. This is our first potentially habitable planet. Astronomers call worlds like this a super-Earth. It orbits a sun-like star at about 1.2 astronomical units, slightly farther than the distance between Earth and our own sun. Larger than Earth, but still rocky, stable, and warm enough to hold liquid water on its surface. This world could be a strong candidate for life as we know it. Temperatures here average around 20 degrees Celsius, about 68 degrees Fahrenheit, a range that could easily sustain complex carbon-based life. A climate like this allows for liquid water, stable weather patterns, and potentially entire ecosystems flourishing on the surface. As you can see, its sky has a soft yellow tint. This suggests an atmosphere filled with aerosols and complex organic molecules, materials that scatter sunlight differently from Earth's nitrogen-rich air. It's a subtle clue that this planet could have unique chemistry, and perhaps unique life. Now we are heading toward our second potentially habitable planet, a unique alien rocky world almost the same size as Mars, orbiting a yellow dwarf star right in the habitable zone. Here, temperatures hover around 28 degrees Celsius, or 82.4 degrees Fahrenheit, warm, stable, and capable of supporting liquid water on the surface. A climate like this could nurture lush environments, dense clouds, and possibly even life forms adapted to warmer conditions. Our third candidate brings us to a world orbiting a sun-like star about 1.5 astronomical units away, slightly farther than Earth's orbit. Yet despite the distance, it maintains an average temperature of 15 degrees Celsius, 59 degrees Fahrenheit, making it comfortably habitable. With a familiar atmospheric mix and environmental conditions that echo Earth's own recipe for life, this planet could easily earn the nickname Earth 2.0. Moving on to our next Earth-like world, we arrive at a truly unique planet. It is the only planet orbiting its star, completely alone, with no neighboring worlds. Surface temperatures reach around 30 degrees Celsius, or 86 degrees Fahrenheit, a warm and stable climate capable of supporting vast oceans. With so much liquid water and a balanced temperature range, this world could easily sustain complex carbon-based life, and perhaps even advanced civilizations. The next one is a gorgeous Earth-like planet with beautiful rings. This planet is a super-Earth with roughly twice Earth's mass and size. A rocky alien world, dense, massive, and geologically active. The presence of these rings suggests that long ago, one of its moons may have collided with the planet's surface, shattering into debris that eventually formed the rings we see today. It orbits a sun-like star at approximately 1 astronomical unit, almost the exact same distance between Earth and the Sun. Surface temperatures average around 26 degrees Celsius, or 78.8 degrees Fahrenheit, warm enough to support vast oceans and potentially rich ocean-based life. Perhaps entire ecosystems thrive beneath these waters. The presence of green vegetation suggests that this planet may have oxygen levels similar to those on Earth, likely produced through photosynthesis. If that's the case, life here could be remarkably similar to life on our own planet. Heading now to our final candidate for life as we know it, we dive into Andromeda's zone of avoidance, a dark, obscure region of the galaxy from the perspective of our previous world. This area is hidden behind dense clouds of dust and gas, a place where light struggles to escape, and where planets may remain unseen even for thousands of years. This planet is almost the same size as Earth, orbiting its star at approximately 0.7 astronomical units. Its host star is a slightly dimmer yellow dwarf, which means that this distance still falls comfortably within the habitable zone, capable of supporting life as we know it. Surface temperatures average around 18 degrees Celsius, or 64.4 degrees Fahrenheit, a climate cool enough for polar glaciers, yet warm enough to allow vast liquid oceans to form across its surface. A world balanced between cold and warm, and a promising candidate for life. It is geologically active, which means its tectonic plates are constantly shifting and reshaping the planet's surface. This level of activity could explain the massive canyons you see here, carved over millions of years by tectonic stress, erosion, and volcanic processes. This lake you see in the video may be capable of sustaining complex aquatic life. Its calm, stable waters could shelter entire ecosystems beneath the surface, from simple microorganisms to more advanced forms of life adapted to this alien environment. And so, our journey through Andromeda comes to an end. We explored distant suns, alien oceans, and planets that could truly host life as we know it. These worlds remind us that habitability may not be rare. It may be common, scattered across billions of planets in galaxies far beyond our own. If life exists out there, it may already be thriving. Thank you for traveling with us across the cosmos. This is Beyond the Rings. Please consider subscribing to our channel to help us create more content like this.